All right. Today we're changing gears kind of drastically. Um, Linux is definitely the best source to perform analyses. But once we've generated our big data files and we need to visualize what's in them, we need to work with them. Um, we kind of have to change environments. So all of these environments that we've been messing with in some degree, like Python is a really good environment for pulling stuff out of files, manipulating files, that kind of thing. At least that's what I use it for. Linux and Bash are the tools that we need to perform analyses and using this software, right? The stuff that we've been doing this semester we can't do on a regular laptop. um, but again, once we get to this point, once we've distilled all the generated and distilled all this data, then um, at least in my world, I transition over to R to either perform statistics or perform data visualization. So really, the only reason I use R is for graphing purposes. Um, but R is super versatile. So it is kind of the go-to stats package. It's the data science package. It's it does so much that it's kind of the package of the scientific world, right? It doesn't matter if it's biologists, mathematicians, engineers, whatever. They're going to use R in some way, form, or fashion. Um, and so today is um, I'm a little nervous. We'll see how this goes, but I'm a little nervous. This is going to turn into like draw two circles, then draw the rest of the owl. And today is pretty much the two circles. Um, so R is its own environment, and so R is a programmable language. And I don't know, maybe y'all will like R a little bit more than Linux. We'll see. Um, but we should recognize that R is effectively a math language. It's just been adapted to do a lot of other different things. So since this is an R language, this is a math language. It inherently has math tools. So for example, if I do 5 plus 4, hit enter, it's going to give me the total of those two counts. This may be a little bit more difficult to see. I have the font better on R Studio, but I at least wanted to introduce R first. Um, and so this is the OG R, and this is what I worked off of for several years before transitioning over to R Studio. And I definitely I get behind the curve in a lot of different ways. Um, I was definitely behind the curve with getting into R, and I was definitely behind the curve with getting into R Studio. I was introduced to R as a statistics package when I was a master's, and I hated it. I hated how it worked, and I pretty much abandoned it until for like 5 or 6, maybe even longer years before I picked it back up again. Um, so R again is math based, but it's also a programming language. Whenever we're dealing with programming languages, then we can start storing variables. So the only variable that we were introduced to, or that I introduced y'all to in Linux or Bash, was the path variable, right? So this is just a variable that stores a bunch of information. And so any programming language, doesn't matter if it's R, it doesn't matter if it's C++ or Python or Bash or whatever, they all have the capabilities of storing information. So, for example, um, if I want to make a variable that's storing the number 4, how I do that is to call my variable. I'm just going to call it X. You can call it whatever you want, but we'll call it X. And then we use an open caret and a dash to effectively mean equals, or to store this information. So I'm going to say X is equal to 4. R can do this, so X equals 4, it will still work and store the variable, but we use equal signs in different places in R. So I don't want. I think it's bad etiquette to use equals as to store a variable. So instead, it's this open caret and a dash. There's probably names for it. There's probably something a specific name for it, but whatever. I'll just say it for as x equals to 4. And y, I'm going to store a variable, but it's make a variable called y that's storing number 5. And then we can um, add those two numbers together. So x plus y should return 9 because x is storing 4 and y is storing 5. And even further, we can make another variable that we'll just call z that's going to store the product of x plus y. And so if we want to access that in different ways to access the information within a variable. So I think that's all I wanted to introduce to y'all with R. For now, I'm going to transition over to R Studio because it's a little bit easier to work with. Um, so, but R Studio is still R, so you still have to have R separately installed from R Studio. So R Studio is effectively a wrapper, a very nice wrapper that interacts with R. And so this left-hand pane is going to effectively be my terminal. This is where I can give it commands to do whatever I want. So it's still going to be the same, x equals 4. Just keep it easier here. And I think the font should be a little bit bigger, should be a little bit easier to see over here. But what's nice about RStudio is that it keeps track of all of the variables that I create. And it's going to keep track of all the variables I create in this top right pane. So I have a value x that's equal to 4. I'll make another my other variable y equal to 5, and that will also be stored in my list over here in my environment. My environments keeps track of all the variables that I use and store. It also keeps track of different types of variables. So we can at least at this lowest level when we're creating variables, we can have numeric variables. So this is the x and y are numerics, but we can also have string variables that contain characters. So I'll just make another variable called test. That's going to be just a string that is just a character, a character list or a character vector or anything like that, and it'll still keep track of that, right? And so again, it's going to be stored in my variable as test, and it's going to be a string. If I want to access that stuff, if I want to access test, just hit test, and it will return that string. Now, whenever we want to store character values or character variables, we do have to use the double quotes or single quotes. At least the word has to be in quotes. So if I do, see if this will give me a complaint. It should give me a complaint. If I do string is equal, if I do test is equal to string, it it should just give me an error. And it's saying strings not found because of what it's looking for is a variable named in this case string I, but string I doesn't exist, so it cannot be stored, and we just get complainy about it. So if we're going to store a character, a character variable, it has to be in quotes. Um, and uh, the last variable that at least needs to be introduced is the Boolean variable. This is also the true false, right? Uh, so in R, every language, how it determines what's true or what's false is dependent on the language. In R, to write out true or false is to you can either use just a single case, just true. It's not all caps, just the T is capped. Oh boy, am I lying? Am I lying? Okay, so that works fine. All caps is fine. I think that's better. Or even just storing, I think a T will be fine. Just storing T will still be a true or false um, statement. Um, so if I'm looking at my value, my variable bool, it's still as a capital TRUE, even though the last time I modified it was just with a capital T. If I wanted to make this variable a false variable, I can also just use the capital F, and now my boolean will change to a false variable. And so these booleans or true false, they have their uses, and um, it, it's not that we're necessarily writing a script to um, ask if if say x is equal to y, return true or not. It's more like we're going to write out a package name or call a package. Um, so these are three variable types, or at least these are three simple variable types: numeric, strings, numeric character, or boolean. Um, but we may also have a vector. And so a vector is effectively a list of characters or a list of numbers. And all of these should be the same type. So if we're going to make a vector, they should all be numbers or they should all be strings or something. But it's just effectively a list or a long list of numbers or strings or whatever. So if I'm making an example vector, how I store and call a vector is just a the syntax of R is to do a C and then parentheses, and within these parentheses I'm going to store all the numbers that I possibly could imagine. All right, so my vector now is stored and it's just containing all 7 of these numbers. So now that I have this vector stored, I may want to sum all of the strings or all of the numbers together in this vector. And so this is why R is so powerful, is that in a lot of ways I don't have to know how math functions work. At least I don't have to do the math functions. I just have to know what sum means and know how to call that sum function. It's going to do the rest of the work for me, right? I don't have to do 1 plus 2 plus 3 plus 4 for it to be done. I can just do sum of the vector and it will return that sum. I can also do the same thing with mean. So if I do mean of the vector, it's also going to give me the mean, the average number, and all of that stuff in that vector. So this is me just working on the R terminal, but this isn't necessarily how I actually want to practice with my R stuff. This isn't how I would be working with R in RStudio most cases. This is where I would test variables or um, test a package or test a line or something like that. But how I would actually operate R in RStudio is to build a script. And so if I'm going to build a script, I'm going to have a new file, go to File, New File, and RScript. And so now I have this new fourth pane in my upper right corner. And so this is where I'm actually going to store my script command. So instead of writing this stuff out every time that I open up my R terminal, I can store all of these commands here. So I can do X is equal to 4, Y is equal to 5, Z is equal to X plus Y. R definitely doesn't get super complainy about white spaces. There are times to take white spaces into account, but these X those two statements are equivalent. So X, where everything's separated by space or no space, those two statements are equivalent and they'll run just fine. Traditionally, me personally, I like to separate everything out by spaces. And then I'll have a cat z. I'll just finish this script off with cat z. So the cat z is just going to print out the contents of my z variable. And so once I have my script made, or at least kind of made, then I'm going to save it somewhere. So here I'm going to save as. And so this is being saved to somewhere on my desktop. Me specifically, I created a directory just called R scripts within my documents where I can save this. So I'm just going to save it here and call it test R for now. Okay. So if I want to run this script and I want to make R run this script for me. The first thing I have to do is to make sure that R is looking in the same directory where my script is located at. And so to make sure that R is doing this, that make sure that R Studio is looking in this R script directory, I'm going to go to Sessions and Set Working Directory. And so I can do this in a couple of ways. So I can either go to Choose Directory and pick my directory from here, or I can set it to my source file location. So my source file location is where my open R script is at. So my open R script that I'm working on now is stored in documents R script. And so then my working directory will just be my documents R script. Again, I can either set that manually or just set it here. And it's a little bit shorter to set it here. So it just runs this command of set WD of where this directory is at. And so if I want to run the contents of this script, if I want to make this work out, then I call the script by using source. And since this is a string, my script name is a string, it's going to be test.r and it has to be inside of quotations. So it's going to be source parentheses, my script name in quotations. I hit R, hit enter, and it's going to print out just the last option that I said print is store x plus y, make that z, and cat or print the z value. Okay. And so this is normally what I would do is I would start editing in my script to do whatever I want it to do and then run it in my terminal. Again, unless I'm testing something out specifically. So why R is so nice, I guess this is the last thing that I'll talk about because we're definitely not done with scripts or anything like that. But right, so what makes scripts nice is if I'm building a plotting script, we're going to plot some data out. I have to manipulate a whole bunch of things, or I have to test a few things out. I'm going to edit it in my script and just keep running it until it does what I want it to do. But we'll come to that in a minute. So R has a lot of tools already programmed into it. It's just this base set of tools inherent to R. The big thing about R is that it's open, it's public. Anybody can write a package that can do anything, and that package can be downloaded and run on your own computer. Right? It's very much a free community-based language that's open to anybody to edit, change, or amend. But in the base tool set, um, at least one of these packages is to create a distribution. So we're going to create a distribution that has a normal distribution. So that, and this is just practicing. This isn't necessarily important. It's just I need to simulate some data first. Before importing data, I just want to simulate some stuff to work with. And so I can use this rnorm function to build up a bunch of data. So the rnorm function works that I can pick 100 points, and I want those points to have a mean. So I want this distribution to have a mean of, say, 10 and a standard deviation of 2. So all it's saying is it's going to randomly pick points around 10. Pick numbers. It's going to pick 100 numbers, but in this final distribution, it should have a mean of 10 and a standard deviation of 2. So when I hit enter, it's going to give me all of these randomly chosen data points. Okay, but but I want to store it. So I'm just going to store this as a norm test, and right, store this as a vector. And remember, just like in Bash, right, the up arrow will bring back old commands. So I can go up and down through my commands just by using my up and down arrows. So my command where I'm calling the rnorm function, but I want to store it as a norm test. And recognize, so now that norm test becomes part of my environment. I can observe it. I know it's a numbers. It's a vector that's from 1 to 100 and contains all these randomly picked numbers. And so why I'm doing this is that having a vector of 100 numbers isn't very useful to me, but I can visualize. And this is the nice thing about ours, is that it quickly visualizes data. And so one of the base commands to visualize data is this hist. And so hist is it means histogram. So it's going to draw a histogram of whatever I want. In this case, I'll make it the norm test. And so now my right pane, it gives me a graph. It just inherently graphs out this data frame, or graphs out all the points in this vector as they would in the form of a histogram. And so a histogram is just these binned categories. And so in this case, so I don't necessarily like all the base graphing tools, but nonetheless, this is the easiest to call. So we're already going to start out. This first number is 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9, 9 to 10, and all the variables that fall within the 9 to 10 range. So in this case, we have 20 variables that are between 9 and 10. And right, so this is a normal distribution. Normal distributions have a peak at a common number, and then they have two tails. Right, unfortunately this requires more statistical explanation than what I'm actually going to provide. This is just an example, and I can plot this out another way by using a box plot. So box plot is also a built-in base function that will give me a box and whisker plot of the same data. So this it's presenting the same data just in a slightly different way. And in this window, I can use this arrow up here to go through the graphs that I've made. This is one reason why RStudio has such an advantage over R itself. So I can go through my plots. Again, it's just plotting the same data just in a different way. And another nice thing about R is that I can adapt, I can change, I can multiply everything within a vector by a single number. So if I wanted to make another vector, so norm, I'll do times 2. I'll have my norm test, and I'm just going to I can multiply every number in this norm test variable by 2. And that will be stored in this norm x2 variable, right? It's just going to be its own separate vector. It's going to be every number in norm test multiplied by 2. So if I want to look at a histogram of norm 2x, there it is, right? So now our mean becomes 20, right? A little bit different from our other tests, and the nice and box plot. So a good thing about box plot is that we can present 2 or more distributions at once with this box plot tool. So I can do my norm test and also the norm x2, norm x2, and so now it's going to present both distributions. So I have my box plot of my first distribution, and then my box plot of this distribution multiplied by 2. And so in these box plots, what these are is that, so this black thick line here is the median value. So this is like the middle number. Um, and each of these bars are percentiles. So this is our data. So 50% of our data will be below this value or above our data or above that value. And this is a 25% percentile. So so 25% of our data will be below this mark, and then 25% will be in this second mark, so from 50 to 25. 25% will be from 50 to 75%, and then 75% or more, right? So I don't know if I explained that very well, but that's the general idea of what's in a box plot. We have these, all of these values are percentiles. So 0 to 25, 25 to 50, 50 to 75, 75 to 100, and then outliers, right? So these are values that will be even higher than general percentiles. Okay. And again, I can store all of that information in my R script. If I wanted to do that here, make these variables and hang out in my R script and then call it again. But I think for now, that's where I'm going to stop for now. So we have these general variables, storing variables, these vectors that contain a bunch of numbers. In most cases, almost all vectors that we'll be messing with will be numbers. And two very basic ways to plot those numbers out is either using the base histogram or the base box plot. That kind of tells us a little bit about the distribution of our data is by looking at it as a histogram or as a box plot. But we're going to get more complex from here. So these are the base graphing tools, but we want to make good graphs, and to make good graphs, we have to use a more complex graphing tool. Um, but we'll save that for next week. So I'm going to kill the stream now and practice with this stuff, and I'll demonstrate some more tools and more tasks on Monday.